Who's seen sine and cosine before? Sine, cosine, tangent. Okay. So this is always the fun, right? So the fun is that you have an idea of what it is. I'm about to define it as a mathematician, right, in a way so that when I go visit the mathematician in the inner caves of Mongolia and I go see her and I say, yo, what's sine and cosine? She's going to tell me exactly the same thing. Okay. So however we've interacted with sine and cosine, make sure that you try and think about it and see if you can rectify whatever it is you think sine and cosine are to what I'm about to say it is, right? And whatever you think it is and whatever I say it is, they better be at least equivalent mathematically, okay? All right. Class lecture is here. I'm going to take a circle. Right, and so I'm going to put it at the origin, radius 1. Right, so I want this to be at the origin. Right, so this is the point 0, 0 right there. And I want the radius to be 1. So I want this distance to be 1. A circle is a set of all points that are equidistant from one particular point, which we call the center. We know the equation of this circle. Remember the equation of a circle? Equation of a circle, x minus a squared plus y minus b squared equals, or the radius squared, r squared. Okay. I want this radius to be 1. Okay. And so the equation of this circle, centered at the origin, is x squared plus y squared equals 1. Right? That is to say that if you went and looked at, why didn't I put this in Desmos and just copy it over, right? If I looked at x squared plus y squared equals 1, and I told Desmos to plot all the points on it, it would get that circle, right? So, right, centered at the origin. Questions about that?
That's the equation of the circle.
That's the equation of the circle centered at the origin with distance 1 from the center. That is the equation of that circle.
Could you go back to the...
Thank you. Yeah. This is the equation of a circle in general, with center AB and radius R. And for us, the center is 0, 0, and the radius is 1. I don't know why I'm wasting my time. I should just go ahead and get rid of this thing and copy the one from Desmos, right? I'm going to take this one. We'll put it there. Okay. Make it a little bit larger. Questions about this? I want to take a ray, centered at the origin and coming out like that. Okay. This ray, put an arrow in this. This ray makes an angle with the x-axis. Theta is going to be the way we denote angles. And makes an angle with the x-axis. This ray also hits this circle how many times? Once. So it hits this circle one time at a coordinate x and y, right? The remark is this, that if, oh, these aren't big enough, that if I change the angle, right, so then I pick a different ray, right? So now this angle we might call omega. Then do I get a different point? I do, right? And so now this ray, so when I pick a different ray, it makes a different angle and gives me a different point. Right? So that there's this association between the angle, the ray, and the point. The angle, the ray, the point. And now I just want to get rid of the ray. Right? There's a relationship between the angle that the ray makes and the point. Right? For each angle, how many points do you get? 1. For each angle, I get 1 and only 1 point. That sounds like for each angle, I get 1 and only 1 point. Begins with an F. A function, for sure. For each angle, I get 1 and only 1 point. That's a function, right? So for each angle, I get 1 x coordinate and 1 y coordinate. So that this point here, this x depends on theta. This y depends on theta. I want to be clear about something. I came here today to talk to you about waves, right? I came here to do 2 things. I came here to talk to you about waves and to talk to you about the triangle, okay? That's what I came here to do today. And so somehow I want you paying attention to how is this going to help us find out what waves are, okay? So now these points depend on the angle. If I change the angle, I'll change the point. So now there is a function that goes from theta to the x coordinate on this circle. There's some function that goes from the angle to the y coordinate on this circle. Okay. Now we know what happens to things that we care about like this. We give them names. Remember, I wanted to know the number that you raised 2 to in order to get 37. Remember that? That number exists. We can't write it out exactly, but it was so important that we gave it a name. We called it log base 2 of 37. It's going to turn out that I'm going to care about the coordinates on this circle. This is called the unit circle. Unit standing for 1. Unit just means the multiplicative unit, 1. Circle of radius 1. This is the x coordinate and this is the y coordinate, and all I'm going to do is call the x coordinate this. The x coordinate is called cosine. The y coordinate is called sine. The exponential function is a function that has the independent variable in the exponent. The logarithmic function is the power, right? It's the inverse of the exponential. The cosine is the x coordinate on the unit circle. The cosine is the x coordinate on the unit circle. That's all it is. The cosine of an angle is just the x coordinate on the unit circle of the unit circle and the ray that makes that angle with the x-axis. The street version is that the cosine of an angle is the x coordinate. The sine of an angle is the y coordinate. Let's get all the other ones out. The tangent of an angle is the y coordinate over the x coordinate. The cotangent of an angle is the x coordinate over the y coordinate. The secant of an angle is 1 over the x coordinate, and the cosecant of an angle, that is bad. The cosecant of an angle is 1 over the y coordinate. Those are all definitions. We're defining trig functions in terms of the circle. All of these can be found just by looking at coordinates on the circle. Questions about this? I've defined a new function. You know what I got to do? I got to talk about its domain, its range, an application or two. Let's do a few examples while we're here. We need to know some coordinates on this circle. Well, it's a circle of radius 1 centered at the origin. Maybe I should put this in green. What point is this? What's that point? It's 1 unit to the right, no units up or down. That's the point 1, 0. What's this point right here? 0, 1. The x-coordinate is 0, the y-coordinate is 1. This point? This point, 1 to the left, none up or down, and this point?
0, -1.
I don't move any in the x, and I move 1 unit down. The cosine is the x-coordinate on this circle. With that definition, it's easy to see, hopefully, what the range is of the cosine. What's the highest value that the cosine can take? What's the highest value the cosine can take?
1.
1. Why? Why is it 1? Because that's the highest what? What's the cosine?
X.
It's the highest x-coordinate. The highest x-coordinate on this circle is this one. In other words, it's the farthest to the right you can go in the circle. What's the lowest value that cosine can take? -1. Okay. Cosine, the cosine of any number should always be between -1 and 1. The sine works the same way. The sine is a y-coordinate. What's the maximum value of sine? The minimum value? -1. Questions? Yeah. So just from the definition, we get that the range, whatever it is, the range of the cosine of theta is -1 to 1. And the range of the sine of theta is also -1 to 1. That can't be more than 1. Questions there? Let me change the view a little bit. It's 90? Does that help? Maybe a little bit. Let's look at some values in the domain. The cosine of 0 degrees. What is it? 1. Why?
Because anything with the thing up.
I make no angle with the x-axis. Here's 0 degree. Here's a 0 degree angle with the x-axis. And now I want to know what the x-coordinate is. It's 1.
When anything raised to the power of 0 will be 1, right?
No, this is the degree symbol.
Oh, that's the degree symbol.
Yeah. Right. The cosine of 0 degrees is 1. What's the sine of 0 degrees? What's the sine? Good. What's the cosine? What's the cosine in general? All right, let's step back. What's the log? The power. What's the cosine? The x-coordinate. What's the sine? The y-coordinate. At 0 degrees, I go to the point that's at 0 degrees. It's this one. What's the y-coordinate of this point?
0.
What's the sine?
0.
What's the sine?
1.
In general, what's the sine?
That's coordinates.
Say it again.
The x.
The sine is the y-coordinate. The sine is the y-coordinate. Okay. What's the sine of 0 degrees?
1.
What point is for 0 degrees? This point, right?
Right.
What's the y-coordinate of that point?
0.
The sine of 0 degrees is 0. Okay. Sine of 0 degrees is 0. It's just the y-coordinate. We got to go around this whole damn thing. All right, we're going to do 30 degrees, 45, 60, 90, 120, 135. We're only going to have to do 3 of these angles. And then hopefully we can use stuff about the circle to help us find the rest of them. Okay. The cosine of 90 degrees. I need to make a 90-degree angle with the x-axis. That takes me to this point. What's the x-coordinate here? 0. The cosine of 90 degrees is 0. What's the sine of 90 degrees?
1.
That's the y-coordinate. It's 1. Okay. Questions there? Okay. This one's 180. What's the cosine of 180 degrees? Negative 1. X-coordinate. Seems like we figured it out. Sine of 180, 0. So we start to visualize this, right? We're going in chunks of 90. What's this angle? 260.
Oh, 270.
270. This one's 180 plus 9 is 270. The sine of 270?
0.
Sine's the
-1.
y-coordinate. Negative 1. Sine of 270 is negative 1. Questions about this? $360 takes me back here again. Okay. Cosine of 360? 1, the x-coordinate. So 360 is one whole revolution around the circle. Takes me back to where I started. Right? And then we just repeat again and again and again. And I hope that kind of hints at the fact that we have some wave-like structure, right? If we just keep repeating over and over and over again. Any questions about anything we talked about so far? Degrees are insufficient. Okay, so we are not going to be talking about, and the reason is because when we start modeling waves in terms of sound, in terms of time, I'm going to say something, right? Sound wave comes out of my voice and then it decays away. What's the domain? Right? If I measure about sound over time, it's time, right? Time is in what units? Seconds or hours, right? Not in degrees. It's not in degrees, right? So far, I've been talking about sines and cosines, and I've been putting degrees in, right? Degrees will not be sufficient to be the unit that I want for stuff to put into sines and cosines, right? So I have to think about changing the units to something else. So let's talk about that. They call that radians. If there's any justice, I still have that. I do. I've been so biased, right? I had made an angle like this, right, and gotten to this point, right? I had made this angle theta, right, to get to this point. Nothing stops me from getting to that point in a completely different way. I could have started here, and then I could have gone along the circle. So this here, this angle is in degrees. And if I measure along the circle, this is in radians. Okay. So now I want to talk about relating the angles in degrees to the angles in radians. Okay, so I want to get another circle going along. Do we remember this? Let's do the original one. Right, what's the total distance around the circle? I'm going to make the radius r. What's the total distance around? Oh, this is good. You told me that in degrees.
Oh, yeah.
Right? So I asked what's the total distance around. She said 360. She gave it to me in degrees. That's great. I want to know it in feet, right? Or in radians. If I gave you the radius as r, how would I find what's the total distance around? 2 pi r, right? Okay. I wore this today for you all. 2 pi r is called begins with a C. The circumference, right? So the circumference of a circle is 2 pi r. Right? Total distance around in radians. Right? Here's a challenge. We got Usain Bolt running around this track. He runs from here to here. The question is, how far did he run? So I want to know this distance. We usually denote that distance by S. Okay. So you're running on some circular track and you want to run from this point to that point. What two things might you need to know in order to answer that question?
Speed and distance.
I just want to know the distance. How would I figure out the distance? How would I figure out S? What two things would I need to tell you? The angle, and what else about the circle? The circumference, or in other words, the radius, right? The circumference would give me the radius, right? But if you just told me the radius and the angle, I should be able to tell you that distance. Okay. So then, that's R. If I told you this angle, then I should be able to tell you S, and I can, right? And it makes sense, right? That if I wanted to know that distance, you need to tell me how wide we're talking, and you would also need to tell me how big is this circle, right? What's the radius of this circle? The formula is S equals R theta. S equals R theta. You'll be given some of these where you'll be given the distance and you'll need to find the angle. You'll be given the radius, you'll need to find, and the distance, or and the angle, you need to find the distance, right? This angle, this particular angle, is never in degrees. Right? This angle is in radians for this reason, right? Because we're talking about, when we talk about Usain Bolt running around this track, he's running in meters. There's no reason theta would be in degrees. Theta needs to be in some other unit. Okay. Questions there about that? And so the question then becomes, we'll see, let's do one. I got a circle like this. I'm going to make that 60 degrees. It's not drawing the scale. That's 10 meters. What's this distance? And so the way we're going to reason through this, right, is that if we had the whole circle, we would be able to answer this. If we had the whole circle, we would just use the whole circumference, right? If we would say, what's the total distance around, we would do 2 pi r, where r was 10, right? But we don't have the whole circle, right? We have part of the circle. What percentage of the circle do we have?
So it's going to be
One what?
1/8.
Not 8. Not 1/4.
It's 1/6.
1/6. It's 60 out of 360, right?
Right.
Is that okay? So whatever it is, the answer is 1/6 of the total answer. Right, so I'm going to write that very carefully because then we'll see how to go from radians to degrees. Okay. So the total distance around is 2 pi r, which in our case is 2 pi times 10, right? Is that okay? For our answer, we need 60 out of 360. We need that percentage of the entire thing will give us the answer. Is that okay? So 60 out of 360 is the percentage of the whole circle that we're talking about. Is that okay? Questions about that? I want to tell you, I want to do some rearranging. So here's some math magic. I want you to notice that this is 60 degrees times 2 pi over 360 times 10. Not anything crazy, right? So I move the 60 out and put the 2 pi over 360. And then the other remark I want to say is I want to reduce this for a moment. This is 60 degrees, and what is this? Pi over 180, right? They both have 2 in common. So I just cancel out a 2. Okay. And this is going to be the factor, pi over 180, that switches degrees to something that we like to measure. When you want to switch from degrees to radians, you multiply by pi over 180. Okay. That gave us 10 pi over 3. The 60 and the 80, they fight, leaving 3 left over. 10 times pi over 3 is the total distance around. But the point of this problem is that here is an example where you see how the radians, when you are given someone, and again, everyone's going to talk in degrees, right? Everyone's going to mention stuff in degrees, and then they're going to want you to give their answer in feet, right? They are trying to tell you that you need to switch from degrees to radians in order to give your answer in feet. The answer is 10 pi over 3 meters, right? Someone came to you and says, yo, that's a 60-degree angle. At 60 degrees, how far did they run in feet? You need, or meters, you need to switch from degrees to feet, or degrees to radians. And multiplying by pi over 180 does that. Okay. What's the point that I'm trying to make? The point is that instead, oh, it's still here. Instead of talking about 90 degrees, or instead of talking about 180 degrees, right? The total distance around the circle, what is it again? That's 2 pi r, right?
Right.
And this is the unit circle. So what is it exactly? 2 pi times 1, which is just 2 pi. The total distance around is 2 pi. So 360 degrees, and 360 in degrees is the same as 2 pi radians. 360 degrees is the same as 2 pi radians. Dividing both sides by 2, 180 and pi are the same thing. 180 degrees is equal to pi radians. This place is funky because here at this school and in USG, everyone's got to take chemistry, right? Everyone's got to take this thing. So it's good. So you all already know how to change units, right? So that, the people grimace, right? So we've got 1 radian. 1 radian is 180 degrees over pi. Or 1 degree is pi over 180.
Always like That's just.
That's always true. Yeah, this is how you go from degrees to radians and from radians to degrees, right? So let's do an example. I got a crew that wants to look at pre-calc. He's just walking out looking at the class. Let's do 60 degrees. I think we already did it, but let's do it now. 60 degrees. Change this to radians. Switch to radians. What's the street version of this? The street version of this means that if I'm on the unit circle and I take a ray, a 60-degree angle ray going out, it's going to hit the circle somewhere. The question is, how far along the circle do I need to walk in order to get to that same point? Right? I'm going to travel along the circle now to get to the same point. And let's see how far I need to travel. Well, I have 60 degrees. Here's the chemistry, right? This is 60 times 1 degree, but 1 degree is pi over 180. 1 degree is pi over 180. This is 60 pi over 180. 60 degrees is pi over 3. 60 degrees is pi over 3. When we talk about sine and cosine in terms of functions, we'll be using radians as the domain. We'll be using radians. We don't know the sine or cosine of 60 degrees yet. Does somebody know? What's the sine of 60 degrees? Okay, I guess we don't know.
Is it a fraction?
It is a fraction.
Looks like the circle.
It's the circle, that's right. So good. So this is excellent. So this is something, again, you have a choice to make at this moment. Some of you are sitting there like, can he just get through this, please? Tell me what I need to memorize, right? Or I'm going to derive all of that, right? I'm going to try to make it make sense so that we never forget again, right? So we never forget again, right? So I know how to get home when I drive from here. I know how to do it. I don't have it memorized. I don't have it memorized how to get home. I know how to get home from here, right? There's a difference, right? I'm not going to forget that. I know how to do it. It makes sense for me to get home from here, right? We want to do the same thing for this. Okay. It's the square root of 3 over 2. Does that sound familiar?
Yeah.
Yes. Okay. Yeah, that's right. That's right. It's the square root of 3 over 2. Okay. All right. Let's do 90. What's 90 degrees in radians? It's the street version. You just multiply by pi over 180. Let's write the street version out. You're probably at a level of maturity where you all write stuff that I don't, but just in case, the street version is, so to go from degrees to radians, multiply by pi over 180. To go from radians to degrees, say it again. Multiply by 180 over pi. This is how you go from one to the other. 90 over 180 is just 1 over 2, right? Pi over 2. Questions there?
So it's supposed to be pi over 1 over 2.
Oh, pi. Oh, it should be pi times 1 over 2. Yeah, pi times 1 over 2 is the same thing as pi over 2. Yeah. So yeah, 4 times 1 over 2 is the same thing as 4 just divided by 2. Yeah.
So then you move forward pi over 2, right?
Say it again?
You can move forward, right? Like pi over 2 equals 1, right?
Pi over 2 equals to
1.
1 what?
1.
Equals 90.
1, right?
Pi over 2 equals 90.
I mean, the sine of 90.
Oh, the sine. Oh, yeah, the sine of, yeah. So the sine of pi over 2, you're beating me to the punch. So the sine of pi over 2 is what?
That's 1.
What is it? What's the sine of pi over 2? is whatever the sine of 90 was.
That's one.
That is 1. 90 degrees. 90 degrees is right here. Or go pi over 2 units on the circle. Right. Point 0, 1, and it's the y coordinate. The sine of pi over 2 is 1. The sine of pi over 2 is 1. What's the cosine of pi? What's pi? What's pi in degrees? 180. That's right. That's right. And remember, we're meeting once this week for the whole week. So if something happened 5 minutes ago, that means it happened 2 days ago, right? So we said on the previous page a week ago that pi and 180 were equal, right? Pi and 180 are the same thing. Okay. So when I say the cosine of pi, I'm really saying the cosine of 180 degrees. What's the x-coordinate here? -1. The cosine of pi is -1. Okay. So all we're doing is the same thing we said before, except we're doing it in radians. Right? We're just doing it in radians. 270. What is that in degrees? 270 over 180. 90 goes into both of those. 3 pi over 2. The sine of 3 pi over 2, 3 pi over 2 is right here, is -1. The y coordinate is -1. Questions there? I want to talk about quadrants. The axes split the xy plane into 4 pieces. Here's one, and I'm going to read it counterclockwise. Here's the second piece, here's the third piece, and here's the fourth piece. Quadrant, quad, standing for 4. First, second, third, fourth quadrant. Okay. Here's something else that people try to remember, right? Just try to remember which one is positive in which quadrant, right? I'm going to say something about the sign. Where is the sign positive? Which quadrants is the sign positive? 1 and 2. Why is that? That's right, because the y coordinates are positive in the first and second quadrants. And the sign is the y coordinate. Where is the cosine positive? Which quadrants are the cosine positive? 1 and 4. Right? Because the x-axis is positive over here, and the cosine is the x-coordinate. Okay. Are we ready? Where is the cosine positive and the sine negative? The cosine positive and the sine negative. 4. Right? I'm simply asking you, where's the x-coordinate positive and the y-coordinate negative? Where's the x-coordinate positive and the y-coordinate negative? Where are they both negative? 3. The x is negative and the y is negative. Questions there?
How does it go?
How does what go?
The 1, 2.
Thank you. So here, in terms of what?
Oh, you already wrote it down.
Yeah, 1, 2, 3, 4. That's right, it goes counterclockwise. Yeah. Where is the sine positive and the cosine negative? The y-coordinate's positive above the x-axis to the left of the y-axis. Good. It just makes sense, I hope. Right? You don't need to memorize that. It just makes sense. Okay. Questions about any of this so far? Okay. Let's do a couple. Let's do 30 degrees. The question is, what is the cosine of 30 degrees? Anybody know? Okay. Let's see here. So I'm gonna make a 30-degree angle here. This is a proof that I'm gonna use some geometry, 30 degrees.
Just switching. Instead of the -1, it's gonna be square root of 3 and 2.
You think it's square root of 3 over 2?
Yeah.
All right, he claims it's the square root of 3 over 2. Let's see if he's right. So here, there's a 30-degree angle, and I'm looking for these coordinates, right? Specifically, I'm looking for the, which coordinate? Yeah, I'm looking for the x coordinate because I wanted to know the cosine. He thinks this is the square root of 3 over 2. Let's see if he's right. Okay. Here's how I'm going to show that this is the square root of 3 over 2. Not just because I said so. Here's the reasoning. I'm going to take another ray here, and I'm going to make this 30 degrees. I can certainly do that, right? What's this distance right here?
60.
What's this distance? 1. It's the unit circle. What's this distance? Is that okay? The question is, what's this distance? So now, what's this angle? 60, right? Tell me the relationship between this angle and this angle. No, these two angles. Are they the same line? Why are these two angles equal? Because these two sides are equal. Is that okay? So these two angles are equal, and this one's 60. What does that mean about these two? They're also 60. Okay? So because that's 60 and the whole thing leaves 120 and these two are equal, they each have to be 60. Is that okay? Yes? That means, what about all the sides? All the sides have the same length. What's this length here then? 1. And isn't this halfway? So what is y? 1/2. Whatever cosine is, I know that the sine of 30 degrees is 1/2. Questions about any of that reasoning? Okay, so the sine of 30 degrees is 1/2. You don't need to memorize this proof. Again, it's my job just to not tell you. You're paying me to not just tell you anymore. Okay. So that's the reason why the sine of 30 degrees is 1/2. Now, in order to find what cosine is, we can utilize the fact that we're on the unit circle and that x squared plus y squared always has to be 1 on the unit circle. When we translate this, this means that cosine squared plus sine squared, I'm just rewriting this, right? That always has to be 1. I'm going to give you notation that saves me from using these brackets, right? The way that people write it is they write it like this. They put the 2 there. Okay. So instead of putting the 2 on the outside, they just put the 2 inside. Okay. It just means you have to square the whole thing. This is the fundamental equation relating sine and cosine. If I gave you sine and you needed cosine, you would go here, right? If I gave you cosine and you needed sine, you would go here. Okay. I just found out that the sine was 1/2, so I'm going to put 1/2 here, and then I'm going to solve for this, right? So the cosine of 30 degrees squared plus the sine of 30 degrees squared equals 1, and I just found out that the sine of 30 degrees is 1/2. So cosine squared 30 degrees plus 1/2 squared is equal to 1. So I plug in 1/2 for the sine of 30 degrees, and now I'm going to try to figure out what cosine of 30 degrees is. Cosine of 30 degrees squared is, plus 1/4. 1/2 squared is 1/4. 1/2 times 1/2 is 1/4. 1 squared is 1, 2 squared is 4, 1 over 4. However you think about it. And now I'm solving for this. I'm going to subtract 1/4 on both sides, and then I'm going to take the square root. Cosine squared 30 degrees equals 1 minus 1/4, 3/4. The cosine of 30 degrees is equal to plus or minus the square root of 3 over the square root of 4. Just taking the square root on both sides. The cosine of 30 degrees is plus or minus the square root of 3 over the square root of 4. Yeah, I subtract 1/4 on both sides. 1 minus 1/4 is 3/4. 1 minus 1/4 is 3/4. Whenever you take the square root on both sides, you get a plus or minus. Which one is it? Plus or minus? Is the x coordinate for 30 degrees positive or negative? Why? It's in the first quadrant. 30 degrees is an angle that lies in the first quadrant. So it's the plus. It's plus the square root of 3 over 2. Go ahead.
I'm trying to get, so how'd you get 3?
Where? Here?
No, the square root.
Here?
Yeah.
So you see how I got this?
Yeah.
Great. So then I have something squared equals 3 over 4. I then take the square root on both sides. Right? And so that leaves x is equal to plus or minus the square root of 3 over the square root of 4. So I got this 3 from subtracting 1 minus 1/4. So if I have 1 minus 1/4 leaves 3/4. And then I just take the square root on each one. Okay. Questions there?
So what's the answer?
The answer is the square root of 3 over 2.
X equals plus minus.
Well, x is just the cosine, right? So if you work this along, I could have left it as x, right? This is still plus or minus the square root of 3 over 2, and then again it's for 30 degrees, so it's in the first quadrant, and so it has to be the positive and not the negative. So the cosine of 30 degrees is the square root of 3 over 2, but 30 degrees, if we write this in radians, 30 degrees, 30 times pi over 180, what is this in pi over 6? That's what it is in radians. The cosine of pi over 6 is the square root of 3 over 2. The sine of pi over 6 is 1/2. I just want to remind you what we're doing, right? So all we're doing is we're investigating these trig functions, sine and cosine, and we're looking at particular values. We only got a couple more to do, and then we'll be good.
So what, I want to be doing the night part.
Say it again?
I want to do the night.
No.
Oh.
See you next week. Let's do the 9th.
Night?
The 9th of September. We have a test to do this week.
Oh, snap.
Yeah, that's right. So please.
So you put the 3 over 4, you put the square root of that because of the 2 that's on the cosine, right?
That's right. I need to take the square root to cancel out that 2. Yeah.
So will this be on the test?
This?
Yeah.
This explanation, no.
Oh, okay.
And it's not on the test. No.
This is just 4.1 to 5, right?
This is 5.1. This is 5.1 right now. Yes. Okay. All right. Let's do 2 more. 45. 45 is special. I want to know the cosine of 45 degrees. Let's write this in radians. What in the world is 45 degrees? 45 degrees is pi over 180, pi over 4. Cosine of pi over 4. And so I'm trying to figure out what this x and this y are. Okay. Now, what's special about 45 degrees? So it splits it like evenly, right? You know what line this is then? X and Y are what? How are they related, the X and Y coordinates, for this point? They're the same. The argument for that goes pretty easily, right? If they were not the same, that would mean that Y was slightly bigger than X, or X was slightly bigger than Y. But if Y was slightly bigger than X, then it wouldn't be 45 degrees. If the Y coordinate was higher, was more than the X coordinate, this would just be a little bit higher. If the X coordinate was bigger, it would be a little bit lower. Right? So, but when they're equal, it makes 45 degrees. Now, we're just back in college algebra, because I know that X and Y are equal, and I also know that X squared plus Y squared equals 1. 2 equations and 2 unknowns. I'm going to use what rule? What method? Begins with an S? 2 equations, 2 unknowns. I'm going to substitute. Right? I got Y equals X, and wherever there's an X, I'm going to put Y. Or wherever there's a Y, I'm going to put X. That's right. So I got X squared plus Y squared equals 1. Anyone know what this is offhand? What's the cosine of 45 degrees? You remember?
Is it square root 2 over 2?
It is the square root of 2 over 2, which we're about to see in just a second. X squared plus Y squared equals 1. Y equals X, so X squared plus X squared equals 1. 2X squared equals 1. X squared equals 1/2. I'm about to take the square root. X is equal to plus or minus the square root of 1 over the square root of 2. Plus or minus 1 over the square root of 2. Which one is it? Plus or minus? Plus. 45 degrees takes us to the first quadrant. What is she talking about then? Square root of 2 over 2. How did you get that? I got 1 over the square root of 2. They better be.
They have to be the same.
They better be the same. That's right. Let's see if they are the same. So then, no one likes square roots in the denominator, so we'll rationalize.
So you have to square up at the bottom, right?
So you multiply by the square root of 2 over the square root of 2. And when you do that, 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 is 2. Or it's the square root of 4, which is 2. And it is the square root of 2 over 2. Cosine of power 4 is the square root of 2 over 2. But what did we say about this particular point? The sine and the cosine are the same. So the sine of power 4 is also the square root of 2 over 2. This is pre-calculus. So stuff like this, if and when you get to calculus, stuff like this you'll have to know like the back of your hand, right? You'll be working through some calculus problem, wanting to know how fast cosine changes at 45 degrees. You're going to do something called the derivative. You're going to take the derivative of cosine, you're going to get negative sine, and then you're going to have to plug in 45 degrees, and no calculus teacher is going to have any patience for you not remembering what the cosine of 45 degrees is. Right? So it's just this type of thing. The challenge here is that what I'm supposed to do, and what most pre-calculus people do, is that they just grill you on this, making sure that you just know the unit circle, memorize it, have it down cold, just so that when you get to calculus, you just know these formulas offhand. I'm not going to do that, right?
But what if you forget over like summer or something? You come back like, whoa, how you got forgot?
But this is good because we get to have a conversation about when you ask me whether this is going to be on the test. It's not. But if you look carefully at the reasoning as to why this is true, that's the method to remember why it's going to be the case, right? So we're going to talk about why you can remember each one in just a second. Okay. And we're going to talk about ways to remember this and make it make sense in a second. Yeah, but that's the real reason to talk about why this stuff is true, because then when you see how it comes up, it's more than just memorizing. You're like, oh wait, this makes sense. This makes sense. Things that make sense you usually don't forget. We're going to summarize in just a second. There's one more angle I want to talk about, and it's 60. There's 30. There's 45. And there is 60. Okay. 45, 60, power of 6, power of 4, power of 3. Okay. All the same things. Okay. I know that this now is the square root of 3 over 2, comma 1/2. We showed that. This is the square root of 2 over 2, comma the square root of 2 over 2. While we're here, this point here is the point 1, 0. This point here is the point 0, 1. This is 0 degrees or 0 radians. This is 90 degrees or power of 2 radians. Please, go ahead.
You probably said it before, bro. Like for the pi over 6, like the square root of 3 over 2 and the 1/2.
Yeah.
Are we gonna, can we just memorize this, or are we going to show like the work?
No, you can memorize it. No, just have it memorized. Now, I'm going to talk about a way to know it in just a moment. Knowing it means that I need to know what this one is. 60 degrees. I'm going to use some geometry. This is 45 degrees, right? What is this distance in degrees? 15 degrees. Is that okay? The nature of the circle tells me this is another what? 15 degrees. This line is just a reflection of this line over the line y equals x. If you were to reflect this line over the line y equals x, you would get this line. You believe that?
Yeah.
Excellent. Well, we know what happens when we reflect something over the x-axis. You get the what begins with an I. You get the inverse, which means I need to do what with the coordinates?
Flip it.
I just need to switch them. The coordinates here, 1/2, comma square root of 3 over 2. It's just those flipped. Okay. That's the first quadrant, and that is about to be the whole circle. Okay. All right, we got all sorts of ways to memorize this, right? So if you want to start at the y-coordinate, as we go through the y-coordinate, we'll see this in a second. As we go through the y-coordinate, what happens to the y-coordinate when I go through the unit circle? Is it increasing or decreasing? It's increasing, right? The y-coordinate is going up, isn't it? So, and let's look at the y-coordinate. It's 1 over 2, the square root of 2 over 2, and then the square root of 3 over 2, isn't it?
Yeah.
So as you go from the lowest angle to higher angles, the y-coordinate is increasing. 1, of course, is the square root of 1. So just go square root of 1, square root of 2, square root of 3. This goes like that. The x-coordinate, of course, is decreasing in the first quadrant.
I think that was just the 1/2.
This is the y-coordinate.
It was 1/2.
Yes, which is the square root of 1. But some people like to remember, oh, it's square root of 1, square root of 2, square root of 3. Square root of 1, square root of 2, square root of 3. That's what happens to the y-coordinate. The x-coordinate is doing the opposite, right? As you move up the unit circle, the x-coordinate is decreasing. It starts off at its largest value, and then it gets smaller. At this point, the way that you're knowing it is you have the image in your head, right? The other way to remember this is that, look, there are only 3 numbers on this whole thing, right? It's these, right? And so if someone says, well, what is the cosine of 30 degrees? Here's the way that I think about it. I think about 30 degrees and I ask, it's either 1/2 or it's the square root of 3 over 2. It's one of those two things. And when I think about 30 degrees, it's under the line where they would be the same. And I just need to argue whether the x coordinate or the y coordinate is larger. Which one's larger at 30 degrees, the x coordinate or the y coordinate? In other words, am I farther to the right or up at 30 degrees? To the right, and therefore the x coordinate has to be larger, and therefore it has to be the square root of 3 over 2. Absolutely, thank you. So when I get 30 or 60, everyone always struggles with whether it should be 1/2 or the square root of 3 over 2, right? And so now I just need to try and figure out, is the x coordinate going to be larger or smaller? If it's larger, it's the square root of 3 over 2. If it's smaller, then it's 1/2. And when I think about 30 degrees and which one's larger, it's more. This point is more to the right than it is up. So that means that the x coordinate is larger. And so it's the square root of 3 over 2. When I think about the sine of 60 degrees is up there. The y coordinate is larger. That is the square root of 3 over 2. Right? I don't have to memorize anything. It just makes sense. Okay. Questions about this? Every other angle is just gotten by symmetry and by the fact that we know that these are coordinates, right? If this is 30 degrees, right, if I go another 30 degrees, it gets me the 120. I'm not going to do all of these. We're going to put up the unit circle in just a second. This takes me the 120. Well, the geometry is clear that this is just a reflection of this over the y-axis. The points are exactly the same, give or take a sign. The x-coordinate has to be negative, question. Right, so that 120 is just a reflection of 60 over the y-axis. And then you just work your way all the way around. Okay. What angle do you think this one is? 15 degrees? 135. Square root of 2 over 2, comma square root of 2 over 2. We know those are the points. We just need to check the sign. That one's negative.
So the negative would be outside the side.
No, it's inside the parentheses. It's just on the x-coordinate. Why?
Because the x on that change. Like x.
We're in the second quadrant,
Yes.
and the x-coordinate is negative in the second quadrant. Okay. Go ahead.
You rewrite that.
Square root of 2 over 2?
Yeah.
Square root of 2 over 2.
There's no negative.
There is a negative.
That's what I was saying. Negative outside the square root.
Outside the square root,
Oh.
but inside the parentheses.
Yeah.
Yeah.
What's that? Like 150-ish.
150 is the next one.
That one is.
This one's 135.
Okay.
Let me bring up a unit circle. Images. This one might do. Uh-oh, I don't know if I'm gonna like this one. Oh, actually, this one's not bad. I thought it was somewhere here. They talk about all this stuff. Oh, I don't see it. Let's do this one. Oh, this one's even prettier. So we'll steal this one. Okay. That's the whole thing. Okay. So 30 degrees gets you 180, another 30, 15, 15, 30, 30, 15, 15, 30, and so forth. Let's make sure we're in the whole circle. And all, again, up to a sign, all the points are the same, right? You're only going to see 1/2, square root of 3 over 2, square root of 2 over 2, 0, and 1, and negative 1, right? Those are the only numbers that go up. Okay. I'm talking about a couple of other things. So now I can talk about the domain of sine and cosine being 0 to 2 pi. Okay. So now we've said that the domain so far is 0 to 2 pi. Okay. I want to talk about that graph. Unit circle here. All right. There's x squared plus y squared. I want to do cosine A comma sine A. Right. And I also want to do A comma sine of A. Let's see what it's going to do. Okay. I want the same slider for both of these. Okay. So then I want A to go from 0 to 2 pi, 0 to 2 pi. And I think we're ready to run this thing. All right. And then one of the things I want to do is I want to get the sine of x. Let's put that down. And there's the sine of x. Okay. So what I want to do is then move this over so we can see why this would make sense to be the graph. Okay. So the circle is going exactly where the point on the circle is doing exactly what we would expect it to be, right? It's going from 0 to 2 pi. Right? Now, what in the world is going on with that blue graph, right? The blue graph is the graph of the sine of x, but the sine is which coordinate? The sine is the y coordinate. So when you look at the y coordinate for the point that's moving around the circle, the y coordinate is being graphed by the green dot. All right, we'll slow it down in just a second, like right now. So when A goes, so where's pi? Pi is 3.14, right? So we go to 3.14, it's not shocking that it's going to be here roughly, right? When A is 3.14, they're going to, oh, that's not bad, right? So when A is approximately pi, the point is here, right? But the y coordinate at this point should be, what's the y coordinate here? 0, which is precisely what the point on the graph is on the x-axis. And as we move this point around the circle, all you're doing is getting the y coordinate, and that is how you get a wave. Right? Now, what we have to do, of course, what I would like to do is to keep going around the circle. Right? So that I don't want this to just go from 0 to 2 pi. Right? I want this to go from 0 to 10 and then run it and just let it go around. And if that happens, then we see that this thing is going to run for longer along this wave, right? So that I want to extend the domain past 0 to 2 pi. That's the last thing we're going to have to do today. Right? So that, what do I mean by the sine of 7 pi over 2? 7 pi over 2 is not on the circle that we just created. What are we going to do for 7 pi over 2? This thing goes all the way up to 10. So what's the sine of 3.5? What's the sine of 11.5? That's more than 2 pi. What's that going to be, right? So yeah, because I do want this wave to go on forever, right? So I want to define this on the whole real line. And what is it going to mean when I want this to be negative? What's the sign of negative pi over 2, right? So from negative 10 to 10, right? That means I'm just going around and then I go backwards. What does it mean to go backwards on the circle? Right. Those are the last things we need to talk about. Any questions about why this looks like the graph? Right. This is why the circle method gives you the wave. Right? And I know that some of us like to think about sine and cosines in terms of the triangle way, right? Which is great, but the triangle way does not give you the very application that Fourier in the 1900s blew up the mathematical world with, right? That every wave can be written in terms of sines and cosines. Okay, great. So let's go ahead and extend the domain. If I want to go for values bigger than 2 pi, I just keep going around the circle. It shouldn't be that surprising that if I wanted to know the sine of 405 degrees, or I should say, let's do the sine of 420 degrees, then I'm going to go around the circle 360 and then go 60 more. Right? So that the sine of 420 degrees, right, takes me around the circle 360. How much is left? 60. So it just takes me to the same place 60 was. The sine of 420 is the same as the sine of 60. Right? They're just the same thing. Okay. The street version is that if you go past 360, then subtract off 360. Just subtract off 360 and it will tell you exactly where you are. 60 is called the reference angle for 420, right? So what we're looking at now is we're looking at all the reference angles. That is to say that if you go more times than one around the circle, you're just going to get back to the same points that you were from the original circle. Right? So that 420 is referenced by 60. Right? So the first few problems in the homework are what are the reference angles for particular angles. You just need to add or subtract 360 until you get to the original circle. Is that okay?
What would be a situation where you're adding it?
Oh, if I give you a negative angle. So I'm going to give you some negative angles first, and then I'm going to ask what the reference angle for that is. Thank you. Okay. Questions about that? So the real funky thing is if I give this to you in radians, right? So if I say, well, what is the sine? Oh, by the way, what's the sine of 60? What's the sine of 60 degrees?
1/2. Square root of 3 over 2.
Which one is it?
Square root of 3 over 2.
It's the square root of 3 over 2. That's right. So if I say something like, well, what's the sine of 7 pi over 2, right? That's 7 pi over 2 is not on this circle, right? But it's referenced by one of these angles, right? And so you could switch this to degrees and then start subtracting off 360. I prefer to do it that way. Or you can subtract off 2 pi, right? But subtracting off 2 pi here just means that you're going to have to be dealing with fractions, right? Which is okay, right? Or the other thing that I like to do is go ahead and divide and find the remainder. Right? 2 goes into 7 how many times? 3 times. So that's 3 whole pi's. What's the remainder? 1 pi over 2. Right? So then you go 1 pi, 2 pi, 3 pi, and then another pi over 2. It's this point. Okay. What's the sign of this point? What's the y coordinate here? -1. Okay. So you just divide. 2 goes into 7 3 times, and you just go around that many times, and then go to the remainder. So that if it's in radians, you can just do that division remainder stuff. If it's in degrees, you can add and subtract as necessary.
You got the pi in.
Say it again?
Like, can you do pi in, the pi by pi?
Thank you. So if I asked you, let's do this one. Let's do 11 pi over 4. What's the cosine of 11 pi over 4, right? So then you say, well, 4 goes into 11 2 times, right? What's the remainder? 3. Is that okay? So this means that this is just the cosine of 2 pi plus 3 pi's over 4. Okay, so that means you need to go around the circle once, one whole revolution of 2 pi. So 2 pi is one whole time, and then another 3 pi over 4, which is right here.
I didn't get that.
Thank you. So do you get this part here?
Yeah, I got that.
You got that? Okay, so now, when you see 2 pi plus 3 pi over 4, right, you're always starting here, and 2 pi is the whole distance around,
Okay.
right? So go 2 pi, which is one whole revolution,
Okay.
and now you have an extra 3 pi over 4 that you need to travel along the circle. But 3 pi over 4 is right there. So this is where you're ending up. And I was asking for which coordinate? The x coordinate, that's right. The answer is the negative square root of 2 over 2.
Could you put down?
Yeah, thank you. Four goes in 11, 2 whole times, remainder is 3. So now I get to go around the circle as often as I want. So now I've justified why I can move all the way to the right. Right. Now the domain of the sine and cosine is 0 to infinity. I can put in any number I want into the sine and cosine. It just represents going around the circle. Let's go backwards. Negative pi over 6. What's the cosine of negative pi over 6? Well, this minus sign just means go in the reverse direction. Right? So we were starting here, and instead of going pi over 6 this way, it's just pi over 6 this way. What's the cosine of negative pi over 6? That's the square root of 3 over 2.
So you go backwards, right?
You just go backwards. The minus sign just says go backwards, and we'll deal with this just in a second. Because I won't want to move it all for this in just a second.
And that's as far as you went?
That was the one I asked first, this minus pi over 6. So that if I wanted to know what the cosine of, that's negative 30, right? Then the reference angle for negative 30 is you add 360, it's just this one. Negative 30 plus 360 is 330. You would add 360. And that's when you would add 360. Yeah. So you just add or subtract 360 until you get on the original circle. Questions there?
I don't get the cosine.
So the cosine is the x-coordinate. So if I ask for the cosine of negative 30, the first thing you need to do is find where negative 30 is on the circle, right? So that's 30 degrees this way. You arrive at the point, and the definition of cosine is, it's just the x-coordinate.
Or I meant the cosine parentheses negative pi over 6 parentheses.
This right here? Oh, so that was the question. The question is, what is the cosine of negative pi over 6? Right, so you can do this in a couple ways. You can either say, well, look, pi is 180, so this is just really cosine of negative 30, and then do this. Or you can go to the circle and move minus pi over 6 in this direction, knowing that pi over 6 is just that. The symmetry just tells us that it's just that point. So pi over 6 that way, it's going to take us, if we go this way, it's going to take us to 11 pi over 6. Yeah.
So is the answer the 11 one or is it 3 over 2?
Wait, I'm sorry, are you saying is it this one or this one?
Is it 11x over 6 or 3 over 2?
Oh, the answer is the coordinate. It's the square root of 3 over 2. Yep. That's right. All right, so now so putting in negative angles just means going in backwards. All right, so what is the cosine of minus 7 pi over 4?
Say it one more time.
What's the cosine of negative 7 pi over 4? 7 pi over 4 is here, right?
Yeah.
That's the square root of 2 over 2. That's right. So if going forwards takes us here, right, then going backwards takes us here. And we wanted to know the x-coordinate.
What does it say?
It's the square root of 2 over 2. Yeah. Questions on this? So again, off the record while being recorded, I'll say again that the unit circle is going to be crucial for you to know hardcore. When you're doing a lot of the homework, have it in front of you. Again, for the test, it'll be pretty straightforward. If it's going to be take home, you'll have the circle in front of you, and it's just using the circle. Okay.
So we click on the circle. Wow.
Say it again.
So just click on the circle on the test. Click on the circle.
There's no circle on the test. You just bring your own.
Oh.
Just bring your own circle. Yeah.
Dang.
Now, I want to be clear. What's supposed to happen is I'm supposed to make you make one during the test. Everybody does this. It says draw your own circle and then use that for the test, right?
So what if you get the circle wrong, then you're gonna get the whole test wrong?
Yeah.
That's messed up.
It puts a lot of pressure on you. It does. But let's be clear. This is good. This is good. But you know that you just need to do those angles in the first quadrant, and all the rest just follow from it, right?
That's still kind of messed up though. Like if I was in my circle, I'm gonna get the whole test wrong.
But you're not going to get it wrong. But you're not going to get it wrong.
Where's the first alignment?
For real?
Oh yes. Oh no. That's the standard to do. Yeah, I did that a long time ago when I was younger and like anal about things. I was like, no, you're gonna have to draw your own. And every week I used to have a quiz. I used to say, here, draw the unit circle. Yeah. Right. Yeah. So I mean, but the point is that like this is not. So the real context of this is that again, this is pre-calculus, and when you get to calculus, most calculus people are not going to be so stringent. They'll let you use your calculators and stuff. Like, it's not this big of a deal, right? The reason why I don't care now is because I'm older and like way more chill. And I understand that like this is not so hardcore that you need to have this super memorized for the rest. That's crazy. That's not really what happens in calculus.
Do you teach calculus?
Oh no, I don't teach calculus anymore. Yeah. I actually had my first class here was a Calc 1 class on Mondays from 6:30 to 10.
Jeez.
You must
Yeah,
love 6:30.
that's good. No. Well, no, I only get to be here once. I only need to be here one time. Like so, yeah, it gets it all done. Okay. What other things do we need to close up? I guess the final thing about this is that I don't even want to go backwards on the circle right now. Okay, so the remark is if we take a look at here's pi over 4, right? Here's minus pi over 4. Tell me about the x-coordinates. They're the same. That's true for cosine. If you go forwards cosine in some angle and you go backwards, you end up at the same x-coordinate. That's the nature of the circle, right? So that if I went 3 pi over 4 this way and then went minus 3 pi over 4 this way, the x-coordinate stays exactly the same. Okay? So that this means something about the negative angles, right? That the cosine of a negative angle, who cares about the negative? It's just the same thing as the cosine of the original one. The x-coordinate doesn't change. So that if I wanted to know the cosine of negative 11 pi over 6, it's just the cosine of 11 pi over 6. I don't need to move backwards at all. A function like this is called even. It's an even function. It's an even function. The reason why we call it even is because it behaves like even powers, right? When you take something to the second power, does the minus sign matter? No. When you raise something to the sixth power, it doesn't matter. When you raise something to the eighth power, it doesn't matter, right? So that's an even function. The sign is the opposite. If you want to know the sign of a negative angle, it's the negative sign of the angle. Right? That is to say that if you look at the circle again, if I wanted to know the sign of negative pi over 6, here's negative pi over 6. It's negative 1/2, which is the negative of what you would get if you did the positive way. So if you want to do the sign of a negative angle, take the sign of the original angle and flip the sign. So if I want to know the sign of negative pi over 3, then I just need to find the sign of pi over 3 and change the sign. And then change the sign. So here's yet another reason why we only need to know a few of the angles in the first quadrant. Right? So negative pi over 3 is not on the original circle, but I know pi over 3 because it's one of the original ones, and I just need to change the sign. The sign of pi over 3 is the square root of 3 over 2, and then I just change the sign. Okay. Let's take a break there. We'll break there. I want to talk about triangles, and then we'll go through the homework. We'll break for 10 minutes.